Another way to present different contributions to sustainability science is through word clouds. That's not the method in which you show different sizes of the words according to the relative importance. This can give you some hints as what are the keywords that might be useful for you actually when you do your search for relevant information. And hey, I'm happy to report climate change is a very important keyword there. Maybe the third in importance after sustainable development itself and environmental sustainability. So that's a source for keywords for you. Now, the entire effort here is to achieve a holistic science. Holistic means whole picture. And this is something new. Traditionally, science was reductionist, meaning that you have something, you split it in pieces and you study the pieces, and then you say, okay, I understand it because I understand different pieces. But this is not enough. We need to also integrate back these pieces into a coherent picture. And after all this time of doing reductionist research, now we have the difficulty of integrating them. So while our science is still reductionist, the big common goal that we have is to achieve this holistic science. And in the public sphere, this is known since almost 20 years ago now as a new social contract for science and scientists that we have to develop together. Again, if you click on the slide, you can find the article of Janko to read for yourself. Now, you already understood how complex the issue is. But that was more about the complexity of the science system itself. But there is another source, even bigger, of course, of complexity. That is the object of study. That is the natural world. We are part of a big complex system with complex subsystems. How to study that? That's a bit overwhelming. So we need hints, we need methods, so that we can use what is relevant for us. The best knowledge map that I found is this one, which you can find also yourself on Wikipedia, and I encourage you to use Wikipedia for science purposes because despite being a public domain, the contributors to these fields in Wikipedia, these entries, these are experts and they generate these articles collaboratively. So they become very good. So I'm relying on this source. It's not good to cite as a scientific reference, but for understanding and orientation is a perfect tool. But even Wikipedia is very big, so we need to use these knowledge maps. What I want to highlight in this story is that you have big chapters and you see like the white bubbles there. But for our purposes, I would highlight especially the phenomenon of self-organization, which is spontaneous order. And this is something most people don't realize, or maybe they understand intuitively, but they don't really believe it. So order can appear spontaneously, and this has important consequences. Then different systems are organized across scales, meaning that different phenomena exist at lower and higher scales. And at higher scales, you may see some properties of the system which cannot be explained by the properties of the subsystems. That is, the whole cannot be explained by the properties of the components of it. And these are the emergent properties. Another highlight that I want to make is that complex systems don't behave in a linear fashion, and I'm going to show a bit more in detail in the next slides. They have a non-linear dynamics, meaning that you meet thresholds and then criticality and cascading effects. Our most important keyword, adaptation, is here, you see it. prominently in the big knowledge map here. And this means, of course, that an adaptive system changes so that it can stay or maintain or increase its fitness in response to changes in its conditions. Now, if we add the element of time to complexity, we see how this complexity sciences developed. And here I'm talking about the sciences, so how we understand the complex systems of the nature. The reason I'm showing this map is not to overwhelm you, of course, or to impress you. That's also possible because that's a nice map. But to show just how a knowledge map can look like with connections and different contributors, if you also want this kind of detail, into the field, and how things evolved from 50 years ago or even more to this year, and what are the most important domains in this year. And you see that things started with complex systems theory in relation to system science and cybernetics and other stuff, and then through self-organization studies and complex adaptive systems and emergence related to mathematical topics, and then computing and social studies related to networks. And today what we have as important clusters of research are on data science and on case-based models, meaning that you cannot just take a model and then apply it to everything. We have such a detailed understanding of reality now that it's better to start from the case and then up to what theories can be useful. A point I want to make on nonlinear dynamics, and perhaps the most relevant phenomenon reflecting that is the self-organized criticality, so called SOC or SOC if you want. And this can be illustrated intuitively with a pile of rice or a pint of sand. What happens is that if you pour the grains like that, you begin to have a pie forming. But the more you pour the grains, you will see some cascades happening at a point. So right before the cascade happens, actually, that's a moment of equilibrium. And then only one grain of sand, when you add, it triggers the entire cascade. Why this happens? That's because if you look on the right at the relation between cause and effect, these complex systems, they don't react in a nice linear fashion, but you have thresholds that generate sudden shifts of behavior, meaning that you have an equilibrium as a tipping point. When that is crossed, what happens is a cascade. This has tremendous consequences in all domains, including in the socio-economic life, and actually the recent economic crisis and financial crisis has been very much described in terms of criticality, tension that was accumulating behind the threshold, and then it just needed a little impulse so that an entire cascade is triggered. Now, at the level of organization of human society, this phenomenon, criticality and cascading effects, means that you have very complex feedbacks, and sometimes these feedbacks lead to feedback loops that maintain a negative phenomenon or perturbation, and that is a so-called vicious circle. For example, that could be the poverty underdevelopment cycle. You are poor, so you cannot develop, and if you don't develop, you are poor. This can happen, let's say, in some countries or in some regions of even a rich country. So it's a matter of how these interactions happen and what are the configurations of the stable feedbacks that happens. Okay, this sounds a bit abstract, but this is just for you to remember what to expect when you want to plan things. All right. you will study more the relations between these arrows yourself. Now, I think these were the main points I wanted to make for this first lesson. From now on, you can continue with your individual study. And let me just highlight, because it's the first lesson like this. The solutions start with the right questions. Always you should strive for the better questions, because better questions lead to better answers, which lead to better solutions. And then what really matters is not what I'm saying here. I'm just giving you some hints to help. But what matters is for you to look for your own answers to those questions. So for you to do, review these slides again. You can go into the links that I provided, and then you can email me the questions, and then I will answer them to the entire class. And of course, as needed, also individually. I give some readings as recommended articles, which you can download by clicking directly there, supposing that the hyperlink will still be there when you try to do it. And this is also important. There is a tool for you, many of you might know it already, which is called Google Scholar. That is, Google does a lot of cool stuff. That's the cool stuff for science. So if you click on that and type your keywords, for example, from the slide where I showed you the words that are the most important in sustainability science, or any other ones that you want, you will receive a list with articles, and in some cases you will see PDF accessible. Use it. Don't read everything, just look what is important. These are not books to read for fun, these are just tools, these articles, for you to find what is relevant. Sometimes it's enough to read the abstract. And of course, I can provide you more hints by answering you. Thank you.